For the accounts that I managed that are related to this example, the goal was to make data transfer as painless as possible for the clients. I put an initiative in place to remove as many barriers to data transfer as possible, and that meant accepting data in any format that was easiest for the client, providing they submitted all required data and that the format that they first provided remained consistent throughout the duration of the contract. What this translated to on my end was writing customized load and data manipulation stored procedures for each client so that the client data would be normalized according to my company's standard. This example shows various programs that I use to load one client file containing UB or Universal Billing Patient data. I wrote one batch file, one format file, and one stored procedure to normalize this client summary data. Looking at this batch program, notice that documentation is in place instructing in the purpose, usage, and operation of the file. We see that standardized infrastructure is in place with a required load directory and load table set up unique to the client. The batch program reads the client file in accordance with the format file specifications and loads it into the client table in the database. In this batch program, an error file is also provided to log load errors. It is standard operating procedure to check the error log and verify success or failure, followed by appropriate action. This is the format file indicating specifications for every field in the client's file. In this file, we see various elements such as the field order, data type, length, delimiter, load position, and field name. Then there is the stored procedure. At the beginning is my documentation included in all of my scripts, documenting necessary information about the script, client, and data. I include the specifications of the client-specific table in the script so that it is documented in a location that makes sense. After the table schema, I declare client-specific specifications and variables at the beginning of the procedure. Then I load the client-specific data into the company table, having all normalized client data. And I normalize the data as it is being loaded into the company table. For this particular client, dates are normalized and client codes are translated to company codes. Error checking is put into place throughout the procedure, and if errors exist, a notification is given and the process is rolled back. Upon successful data load and normalization, I perform housekeeping, dropping the client-specific table and put an indicator in a data load table indicating that the client data is in queue for the full standardized processing that comes next. And this is the full standardized processing that comes next. It is complete data processing that I created as the solution to produce data with good integrity for every client, quickly, efficiently, and comprehensively. I developed 10 procedures for data processing of multiple accounts at once. Additionally, I developed 2 supplemental procedures to be utilized when necessary. In these procedures, I clean data and perform standardized conversions and update clinical indicators. I assign cohort risk and complication assignments and identifications. I perform data archives, create an exhaustive audit report for each client for each load, and load data into production tables used for reporting and by company consultants and department teams and client administrators, physicians, nurses, and executive staff. Finally, I aggregate data for analysis of outcomes. Altogether, these procedures total nearly 200 pages of clean, organized, and well-documented code. The first procedure, start, has my usual documentation at the beginning. The executed procedure tests input variables such as receipt date, encryption, and data transfer type, checks for client data existence in client tables, and checks for correct provider data in the universal billing summary and detail data. It checks for correct HIPAA assignments such as age, length of stay, and date calculation accuracy based on de-identification assignments. It checks for unknown physician groups. It deletes data from load tables if they fail data integrity checks and reports errors and ends the process if applicable. If data have good integrity so far, it populates a data counts table required for continued processing and kicks off the next procedure, clean data. An item of note in this procedure is the efficiency of the error reporting. Note that the procedure does not stop immediately as each error is encountered. Rather, it checks all errors. Then if errors exist, it reports all of them at the end so that they all may be corrected at once. This is contrary to what was happening before when one error would be found and reported, the process stops, the error corrected, and the process rerun, only to find another different error later in the process. Then the process would stop, the error corrected, the process rerun. Then if a third error was found, the process was stopped, the error was corrected, and the process was rerun. This way of operating continued until all errors were corrected. This original procedure was a very inefficient way of operating that wasted valuable time of the operator, as subsequent reruns were executed that could be avoided. Subsequently, my new procedure checked for all possible errors prior to stopping. Then, if errors were found, the procedure stopped and reported them only once. Then the operator corrected them all at once, reran the process one more time, and the typical result was that data integrity checks passed completely the second processing, and the data load process continued. Additionally, one more item to note is that this was a multi-client processing environment. What that meant is that if some client data had bad integrity, but another client's data had good integrity, the process was smart enough to remove the client with bad integrity from the load queue, while at the same time continuing to process and load another client's data that had good integrity. The client's data that could not be loaded due to bad integrity was reported so that the operator could address the issue, fix the data, and reload it later, while still allowing the processing to complete for those clients that had data with good integrity. This meant that clients' data with bad integrity would not delay getting other clients' data that passed tests to production quickly, so that it was available as soon as possible for the end users that required it. Prior to these new procedures that I developed, clients' data were loaded one client at a time, and this resulted in delays on my company's part in getting data as quickly as possible to the clients that we serve. So by combining multiple clients in one process, I increased efficiency and speed of my company's deliverable. The second procedure, clean data in the client data load process, first cleans data fields such as trimming excess white space, removing unnecessary periods and characters, and converting empty strings to null. Then it performs code and date manipulations and or calculations such as age and date calculations and groupings and standardization of codes. When it is complete, it executes the third procedure in the process, cohort patience. This third procedure groups patient records into contracted cohorts, archives patient records not in contracted cohorts, assigns cohort physician to patient records, assigns risks and complications to patient records, updates clinical indicators, populates a required data counts table for the current processing, and executes the next procedure, reject, for the data load process. There is a lot to this process of which I will not go into detail in this chapter. If you would like detail about the work that I do for cohort grouping and you have not been able to get the information that you need from my other chapters where I specifically give an overview of the work that I do related to the logic involved in defining cohorts, then please contact me and I will be happy to expound on this one-on-one. One thing to note in this procedure is that I archive patient records that my company will not be using. This is a tactic that I use often in general, as data archival is useful for on-demand record keeping, research, and troubleshooting if any issues arise. As a result, I make sure that I keep archived data readily available, but in a separate location from the data used in reporting that is in production. This enables efficient, decluttered resources. The fourth procedure, reject, performs all exclusions specific to the cohort as they are defined, performs all rejections due to bad data integrity that are not cohort specific, populates a required data counts table for the current processing, and executes the next procedure warning for the data load process. One thing to note in this procedure is that I put together query parts dynamically and execute each different query in a loop. This avoids repeating the same query several times throughout the script with only slight variations, which can be problematic with errors and time-consuming when troubleshooting bugs. By dynamically building the query, I keep the logic neatly together so that it can easily be read in one location and the logic in execution remains consistent. This type of design throughout code minimizes bugs and translates to less time that the developer must dedicate to development, thereby saving the company money by efficiently employing their developers' time and not hiring more developers than are required. The fifth procedure, warning, performs actions to warn about issues found in the data, then kicks off the next procedure, audit. Regarding this entire process, included in all 12 procedures, note two things. First, I check for technical processing errors in every step and make provision to gracefully terminate the process when these errors exist. Second, I keep a detailed log of processing activity every step of the way. This is done so that if any issues arise, the log can pinpoint exactly where the issue occurred so that it may be corrected and resolved as quickly as possible. This efficiency in quickly resolving problems decreases time from data receipt to deliverable. The length of time from data receipt to deliverable was a tremendous pain point for my company before I developed the new procedures. The reputation of my company was suffering. My solutions addressed the problem and put my company in an excellent, favorable light with the client when it came to our deliverables of data. The sixth procedure, audit, prints audit and summary reports to the screen for the operator to review. The audit report produced shows an audit header with summary information about the current data load, a duplicate patient report, cohort exclusion audit report, rejection audit report, warning audit report, physician specialty report, code distribution report, case count summary, and 4 appendices listing missing physician data, cohort exclusion values, rejection values, and warning values. After printing the report, the load process is stopped so that the audit reports may be reviewed. I will walk through an example of one of the reports produced by this procedure in my next chapter. procedure approval indicates to load, reject, or publish client data. It is executed after the audit report has been reviewed. It checks for valid input variables given by the account manager, deletes rejected data from client load tables, notes rejected data in a data counts table, and executes the next procedure, client load, if approved data with good integrity exists. The 8th procedure, client load, loads all client data to my company's product client detail tables. In the process, it assigns a new randomly system-generated patient ID specific to my company only for patient data confidentiality compliance required by HIPAA. Client detail tables include patient detail, diagnosis, procedure, room, and revenue code tables. At the end of the procedure, housekeeping is performed to keep our database in excellent, optimized, and uncluttered condition, and to report final actions to keep the account manager informed and alerted to any final issues. This is the end of the load procedure that is done during the day live with the account manager. The 9th procedure, publish, is executed in circumstances when, in the 7th procedure, the data were only indicated with an approval but not published. In some circumstances, such as when the QA analyst has not yet had an opportunity to review an audit report, data are approved to load to the staging area, but they are not yet approved for production migration. Therefore, this 9th procedure provides for this circumstance. It performs the same action as the 7th procedure once the data have been approved or disapproved to publish, and it sets the indicator that tells whether or not the data stage will be published to production or denied from production and deleted. Finally, the 10th procedure, and last in the regular data processing and load procedures, aggregates data and stores newly aggregated data. This data is used in client reporting deliverables. The procedure inserts new data to tables that contain data in queue to be migrated to production. The procedure is executed nightly if new data exists to be published prior to production migration. A few examples of data migrated or aggregated are summaries of cohort, total charges, counts of indicators by discharge, days of week by physician, or counts of indicators for specific risks, comorbids, and complications. Then I wrote 2 additional procedures to be executed as needed. The re-aggregate procedure re-aggregates data for specific providers. If, for example, a physician group or specialty update are made to the database and they need to be implemented into the aggregate data for reporting purposes. This procedure checks for valid input variables from the account manager, updates the publish indicator to true to indicate re-aggregation and publishing, and shows a report of actions made to the data so that the account manager is informed and alerted to any issues. Then the second additional procedure, destroy client data, is executed in order to delete all client data for specified providers. It is executed when the client's contract has expired or has been terminated, and the client has denied my company's request to use the client data after the termination. This procedure checks for valid input variables from the account manager, deletes client data from all product load, patient detail, cross-reference, and aggregate tables. It logs the destroy date and reports the providers that were removed from the product's database. So you see, this is a comprehensive data processing and load environment that I developed from start to finish. In the next chapter, I will walk through the audit report so that you may have an idea of what to expect if you hire me regarding my data integrity checks and reporting.